All right, let's talk about a piece of tech that's kind of the unsung hero of the modern industrial world. It's making everything from giant factories to the air conditioning in your office building way smarter and way more efficient. We're diving into the variable frequency drive, or as you'll hear it called, the VFD.
So here's the game plan for today. First, we got to understand the problem. Why did we even need these things? Then we'll get into the nitty-gritty. What exactly is a VFD and how does it pull off its magic? After that, we'll talk about the big payoff, because it's huge, and even touch on how you program these things and what to do when they act up.
Okay, so to really get why VFDs are so cool, you have to picture how things worked before them. We're talking about the old-school, brute force method of running a standard electric motor. Think about this. You get in your car, but instead of a gas pedal, you've just got a big on-off switch. It's either 0 or full throttle, nothing in between. Sounds crazy, right? Well, that is exactly how most electric motors operate without a VFD. They are either completely off or they are running at 100% full blast all the time, even if you only need, say, 30% of that power.
And this all-or-nothing approach, it comes with some really big problems. I mean, first off, you're just torching energy. But it's more than that. You're also physically punishing the equipment. Every single time that motor slams on, it's like a mechanical shockwave goes through the whole system. The shafts, the bearings, the couplings, they all take a hit. That means more wear, more tear, and yeah, more expensive breakdowns.
So what's the solution to all this wasted energy and mechanical abuse? Well, this is where the VFDs steps in to save the day.
You can think of a VFD as a super smart power manager for the motor. It sits right between the power grid and the motor itself, and its whole job is to take that raw power and fine-tune it, giving the motor exactly the amount of juice it needs to run at the right speed, and not a drop more. So how does it do that? It's actually a really cool three-step process. First, it takes the AC power from the wall and the rectifier stage, turns it into DC power. Then that DC power gets stored and smoothed out in what's called the DC link. And finally, this is the magic part, the inverter takes that smooth DC power and chops it up to create a brand new, perfect AC signal at the exact frequency the motor needs for the speed we want. It's like a custom power factory in a box.
And how in the world does it build that perfect new wave? It uses this incredible technique called pulse width modulation, or PWM. The inverter is basically flipping a switch on and off thousands of times a second, creating these tiny little pulses of DC power. By controlling the width and timing of those pulses, it can perfectly sculpt a new AC sine wave for the motor. It's really amazing when you think about it.
Okay, so why bother with this whole song and dance of converting power from AC to DC and then back to AC again? I mean, it sounds complicated, right? Well, the reason is that the payoff is just massive. And it's not just about controlling speed.
And here it is, the #1 reason businesses fall in love with VFDs, the energy savings. We're not talking about a few percentage points here. In applications like pumps and fans, where the load changes a lot, you can slash your energy bill by 20 to 50%. I mean, just think about that. That is a game-changing amount of savings.
But the savings are just the beginning. The benefits just keep stacking up. Remember that violent jolt when a motor starts? Gone. VFDs give you a soft, smooth start, which means your equipment, the motor, the belts, the bearings, everything just lasts longer. The whole system runs quieter, you get less vibration, and you have this incredible, precise control over your entire process. It's a win-win-win.
Now, a VFD isn't something you just plug in and walk away from. It's a smart device, and to get all these awesome benefits, you've got to tell it what to do. And the way we do that is by setting its parameters. The easiest way to think about parameters is like the settings menu in an app on your phone. Each parameter is a specific knob you can turn or a value you can set. You can tell it, hey, don't ever let this motor run faster than this speed, or take exactly 10 seconds to ramp up to full speed. You're essentially customizing the VFD's brain for the specific job it needs to do.
Okay, let's look at some of the absolute must-know parameters. You've got your ramp-up time, that's your acceleration. Ramp down time, that's your deceleration, how fast it stops. Then you set your speed limits. Max frequency is your top speed, your ceiling, and min frequency is the slowest it'll go when it's running. Seriously, just by tweaking these 4 settings, you can completely change how that motor behaves.
All right, so beyond those basic settings, modern VFDs are just loaded with other cool features and built-in smarts that make life so much easier when you're running and troubleshooting these systems.
For instance, you've got something called jog mode. Need to just bump a conveyor belt a few inches for maintenance? Jog mode lets you do that. Or what about a flying start? This is super cool. It lets the VFD safely grab control of a motor that's already spinning, like a fan being turned by the wind. And then there's DC braking, which basically slams on the brakes electronically to stop a motor super fast without needing a physical brake.
But honestly, one of the most powerful features of any modern VFD is its ability to diagnose itself. See, the drive is always watching. It's monitoring its own health, it's monitoring the motor, and if something goes wrong, it doesn't just die. It tells you why it stopped, by flashing a fault code.
And this is a huge time saver for anyone doing maintenance. Instead of spending hours guessing what's wrong, a technician can walk up, see F2 on the display, and go, overvoltage. The motor's probably stopping too fast. Or they see F11 and know right away to check if the motor is overheating. It turns a potential mystery into a clear, actionable problem.
So if you take one thing away from this, it's this quote right here. A VFD gives a motor the finesse and nuance of a gas pedal, getting rid of the old, brute force on-off switch. It brings intelligence and efficiency to what was once just raw power.
This tech is really a cornerstone of modern automation and, frankly, our push for a more energy-efficient future, which kind of leaves you with a big question, right? Now that we have this incredible intelligent control over almost any motor out there, what other giant efficiency problems are we ready to solve next?
Like, share, and subscribe for appreciation and more content.